Well, welcome everyone, especially Matt. It's great seeing you again. Um, First, I want to introduce Matt, and then I'll introduce the journal, and then we're going to head into the presentation, and at the end, we're going to have a bit of Q&A. So dear colleagues, friends, and distinguished guests, good evening, good morning, depending on where you are. I'm Behzad Rismanchi from the University of Melbourne. I'm also one of the editorial board member of the Journal of Building Design and Environment. It's truly my pleasure to welcome all of you to this forum. The journal is committed to advancing the dialogue around the built environment through global academic exchange. The Frontier Forum series was launched to create a dynamic platform for scholars to share pioneering research, exploring emerging technologies, and engage in meaningful conversation. If you'd like to know more about the journal, please feel free to contact us or visit the website. The links are on the screen as well. Today, we're truly honored to welcome Professor Matt Santomaris, a renowned expert in urban environment and sustainable energy. His groundbreaking work on contracting urban overheating has had a significant impact worldwide. um, I admire many of his work, and I'm following his work constantly. I believe many of you attending online also know Matt and has read his work as well. But before going into a more in-depth introduction of Matt, I just wanted to share some slide about the journal. The journal was founded in 2023 as an international global gold open access journal, providing a high quality platform for researchers worldwide. To ensure academic excellence, the journal follow a rigorous single-blind peer review process and publish 3 issues per year. At the moment, as part of commitment to supporting researchers, the journal provide full waiver of all article processing charges for accepted papers until 2029. What this allow scholars to publish their work free of charge. With the target to reach an impact factor of around 5, the journal aims to establish itself as a high impact academic platform in the field of building design, environmental sustainability, and urban development. There are a number of QR codes that you can see on the screen. The first one will link you directly to the editorial team for any inquiries that you have. The second one link you to official WeChat of the journal. The third one connect you to a scholar exchange group of the journal, where scholars can stay informed about the latest research and academic discussions. And the fourth one connect you with the LinkedIn page. The journal is basically guided by a distinguished editorial leadership team. Honorary editor-in-chief of the journal, Professor Jian Kang from University College London, is a globally recognized expert in architectural acoustic and the built environment. His leadership play a pivotal role in shaping the academic vision of the journal. The journal is jointly led by 2 editor-in-chief, Liamo Zhang from Huiyazhang University of Science and Technology, and Professor Wang from East China Zhejiang University, who is also a fellow of the European Union Academy of Science. Dr. Son is also executive chief editor of the journal. Altogether, the editorial team of the journal is committed to upholding the highest standard of academic quality and relevance, ensuring that the journal continues to reflect the latest advancements in building design and environmental research. We welcome scholars worldwide to engage with the journal, submit their research, and contribute to advancing knowledge in these critical fields. To ensure the highest standard, the journal is at the moment supported by a global editorial board members. Currently, we have about 55 scholars from 17 different countries participating in the journal. In addition to the regular issues, the journal actively organizes special issues on emerging topics. At the moment, you can see two of them on your screen, and then the link is also provided on the website if you are interested. The last part that I want to talk about is the SCP, which is the International Society for Smart Construction and Production. It was founded by 10 leading academics, including Professor Wang, focus on advancing smart construction and manufacturing technologies, organizing from the Australian Advanced Technology Research and Innovation Alliance. It has become a key global platform for research, innovation, and industry collaboration. Without any further ado, I want to briefly introduce Professor Matt Santamaris. There's no way that I can cover his whole bio, but I'm just going to stick to a very short bio. Professor Santamaris is a globally renowned expert in high-performance architecture and urban sustainability. He's the Distinguished Professor of High-Performance Architecture at the University of New South Wales, Australia, and has served as the visiting professor at several prestigious institutes around the world. He was also the former president of the National Center for Renewable Energy Sources and Energy Saving in Greece. Professor Santamaris has been recognized as the top-cited researcher in building and construction by Stanford University from 2009 to 2022, and has been named a highly cited researcher by Clarivate Analytics for 4 consecutive years. We're truly honored to have Professor Matt Santamaris with us today. Let us warmly welcome him with a clap that people can try at home. So I'll pass the floor to April to share the screen.
May I start?
April, over to you. Yes, yes, please, Matt. Please, over to you.
Thank you so much, Behtat, for the introduction. And thank you so much for the, let's say, invitation to give the lecture. It's my honor to be here with you. We will discuss about urban overheating and the mitigation technologies that we have developed the last years in order really to, let's say, mitigate urban heating in our cities. Next one, please. Is it really urban overheating a real problem? Yes, it is. Actually, we have 13,000 overheated cities in the world, and about 1.7 billion people live under very severe overheating. Just to understand that since the 80s, the number of overheating hours has increased by a factor of 3. Another very important, let's say, point that has to be, let's say, mentioned is that during the last 10 years in China and in India, the heat wave exposure increased by an average of 508 million person days per year. So we face a very serious problem of overheating in our cities. Next one, please. Understand really the impact of, let's say, regional overheating, urban overheating, compared to the global climatic change, I made, let's say, the following graph. I just plotted the number of cooling degree hours in a coastal meteorological station in Sydney, which is not influenced at all by urbanization. And in the 90s, the number of overheating, or the number of cooling degree hours in the specific, let's say, station was close to 280. In our days, the number of overheating hours or cooling degree hours in the same station without urbanization has increased by about 33%. This is the impact of global climatic change. But once we move in the center of the city of Sydney, then the number of cooling degree hours increased by 81% compared to the cooling to the coastal, let's say, station. And this is the impact of urbanization. And unfortunately, when really we calculate the cooling degree hours in the western part of Sydney, which really presents the highest problem of overheating, the number of cooling degree hours increased by 300%. So you understand that in a city and in a distance of about 50 kilometers, we have a tremendous difference of cooling degrees hours or of cooling needs or of overheating, and the impact of global climatic change is really close to 30%, while the real impact of the local climatic change of the city overheating is close to 300%. Next one, please. Which is the impact of the higher temperature in cities? First, it increases the energy consumption for cooling purposes. Also, decreases the efficiency of the power plants. Another very important problem, it has to do with the increase of the peak electricity demand, which obliges utilities to build additional power plants. Also, it has very important environmental problems, increases the emission of pollutants from power plants, increases the concentration of ozone, and also affects very much heat-related mortality and morbidity, and affects also mental health problems. But also has an important impact on our social life, because it lowers the productivity of population, increases the risk of accidents, and affects the survivability of vulnerable population. Next one, please. Do we have enough evidence about, let's say, the impact of urban overheating? Yes. As it concerns the energy consumption, we know that in average, urban overheating causes an energy penalty close to 240 kilowatt-hours per person in average. In some cities, the penalty is higher, in some other cities a little bit lower. So each one of us has really to pay close to 240 kilowatt-hours per person because of the overheating of cities. On the other hand, peak electricity demand is increasing tremendously because really of the very important penetration of air conditioning during really the hot period. This obliges utilities to build additional power plants to satisfy the demand, and of course this increases the cost of electricity. At the same time, we know very well that for each degree of temperature increase, the efficiency and the power output of, let's say, the thermal and nuclear power plant is decreasing by 0.6%, which means that during a day of a heat wave, the, let's say, decrease of the efficiency of the power plants is really close to 6%, which is really very, very high. Next one, please. The problem of the higher demand for electricity during heat wave started to be a very serious problem during the very last period. Why? Because during the period of heat waves, in most really of the nuclear and also thermal stations, there is no possibility for cooling. Why? Because the temperature of the rivers and the temperature of the lakes, which is used really for the cooling of the stations, is increasing, let's say, and in this case cannot be used for cooling purposes. Under these conditions, the, let's say, output of this station is very limited or even zero, and this results in a tremendous increase of the price of electricity. Just to understand that during heat waves during the very last years in Europe, the price of the spot of electricity of the megawatt hour increases by about 10 times, or a factor of 10 during, let's say, the period of heat waves. And of course, this cost is transferred really to the consumers. Next one. Also, another very serious problem that we face because of the overheating has to do with the electrical grid failures or the blackouts. Unfortunately, because of the very high demand of electricity and because really of the sewage problems which is caused by the overheating, we have more and more blackouts and grid failures. It is characteristic that in the United States, during the last, let's say, 10 years, the number of blackouts has increased by about 150%, and you see the graph. As a result, this has a tremendous impact on, let's say, the consumers. In a very recent, let's say, electrical grid failure in the Pacific Northwestern zone of the United States, we had 600 excess deaths, 3,500 emergency hospital visits, and of course a lot of electricity to tens and thousands of citizens in the area. Recently we have a very similar, let's say, a very serious blackout in, let's say, in Spain and in Portugal, which is not really because of the overheating. But this is also caused because, let's say, of similar problems. Next one, please. A part of the energy problem, urban overheating affects very much really the concentration of the pollutants in the atmosphere and mainly of the ozone. This is the result of photochemical reactions in the atmosphere which are accelerated by let's say, the high temperature and the high solar radiation. In this case, ozone is a toxic gas that really creates a serious problem and perhaps really creates a very serious number of deaths per year. According to the World Health Organization, we may have about, let's say, 600,000 additional deaths per year because of the increased concentration of ozone in the world. Next one, please. A part of the serious increase of the concentration of ozone caused by the urban overheating, the extended use of power plants increases the emission and the release of, let's say, pollutants by the power stations. Now we know that for each degree of temperature increase, the release of, let's say, pollutants by the power plants is close to 3.5% per degree, which means that during a day with an overheating of 10 degrees, we may have 35% more pollutants emitted by the power plants. Next one, please. So, unfortunately, the energy and environmental problems are not the only problems that we are facing because of the overheating. The problem to the low-income population caused by, let's say, high temperature in cities is a very, very serious problem. Unfortunately, low-income population lives in deprived urban areas with very high overheating. Also, the quality of housing, really of low-income population, is not the proper one, and this really creates an important indoor overheating problem. The lack of resources really to compensate the overheating puts these people under stress. It is characteristic, for example, that in Portugal, a very developed country of the European Union, a low-income population can cover only 2% of their cooling needs. Next one, please. And a lot of measurements and monitoring campaigns that have been, let's say, performed in low-income households during heat waves or during the warm period have really shown that people, unfortunately, or low-income population is living under, let's say, very high temperature. You see, for example, the results of a recent, let's say, monitoring we had in Western Sydney, and you see that people used to live under 40 degrees during a heat wave. Unfortunately, because they try to be protected and they close doors, windows, everything, the indoor concentration of pollutants was 3 to 4 times higher than the threshold. So because of the overheating, low-income population is living under, let's say, tremendous excess, very high temperatures, and also very high indoor pollution. Next one, please. And we have really enough evidence now that there is a social, let's say, problem associated with low-income population. Why? Because in most part of the world, and especially in the United States and in Europe, low-income population is living in overheated areas. You see in the graph that really the distribution of white people, which is represented by, let's say, the orange color, and the distribution of low-income people, Hispanic and Black people in the United States, against really the temperature in the neighborhood they used to live. You see, for example, that Hispanic and Black people, low-income population, is living in areas of very high temperature, of very high overheating, and this, of course, has a tremendous impact on their quality of life. Next one, please. This is also very clear, let's say, when we compare the city, let's say, surface temperature against the income. You see results from Los Angeles, and there is a very clear, let's say, trend where low-income population is living in areas of very high, let's say, surface temperature, while let's say, high-income population is living in areas with, let's say, higher greenery and higher proportion of greenery and also much lower, let's say, surface temperature. So there is a clear social impact that really is associated with urban overheating. Next one, please. And this really has an impact not only on the energy consumption, it has an impact also on the health of the population. It is characteristic that heat-related mortality in the low-income population below 20 years old is 3.7%, while in the high-income population, the same group but in the high-income population is almost 2.1%. So low-income population pays a very important penalty, really important health penalty because really of the lack of resources. Another important, let's say, element that has to be mentioned is that in New York, you know, the black population and the white population is almost 50-50, 50% black, 50% white. Unfortunately, heat-related mortality of the black population is almost the double than that of the white people. Why? Because they are living in areas where temperature is much higher and also they don't have the proper protection in their houses. Another important issue is that in the United States, the mortality risk of the low-income population during heat waves is almost 220% higher than for, let's say, the the high-income population. So you understand that there is a very important health penalty that is paid by the low-income population because, you know, of the overheating. Next one, please. And this brings us to the very serious problem, the impact of overheating on health. We know very well that the human body, when it is exposed to temperatures beyond a certain threshold, the thermoregulation system cannot offset the impact of extreme heat, and this results in increased global mortality and morbidity. Who really is affected by that? Elderly and young population is the most vulnerable population group. Those with pre-existing health problems like respiratory, cardiovascular, or mental health problems, those using medication, and those that they lack really the economic assets and also the lack of the local infrastructure. Is it a serious problem, heat-related mortality and heat-related morbidity because of the overheating? Yes, I have to tell you that in Europe, heat-related mortality for age population above 65 years old has increased by 85% between 2004 and 2021. So you understand that this is a very serious problem. According also to the World Health Organization, the magnitude of the heat-related mortality in the world is close to 500,000 persons per year. So we are losing 500,000, let's say, people per year because of the overheating. Next one, please. As I mentioned before, although we believe that the main, let's say, targets of the overheating is the age population above 65 years old, recent studies show that unfortunately this affects very much really babies, young population, between 0 to 4 years old. And you see from the graph that there is a very serious increase of the mortality as a function of temperature, really for, let's say, very young, let's say, population. Next one, please. What about the future? The actual forecast by, let's say, the official institutions in the world shows that in Southeast Asia, in South America, in Africa, in South Europe, is going to be a tremendous increase of heat-related mortality because of the overheating. This, of course, has to do with many parameters, and we hope that this will not happen. But unfortunately, the continuous increase of the temperature, the increase of the overpopulation, the lack of proper standards in these areas bring us to such a high number. And let's say that this is going to be one of the major problems in the specific areas. Next one, please. We know at the same time that during the period of high temperature, human aggressivity is increasing tremendously. The number of, let's say, crimes committed during the hot period is increasing by a factor of 6 or 7 compared to, let's say, the rest of the period. And this is very much related, next one please, to the serious increase of the mental health problem. Next one please. The serious increase of the mental health problems during the hot period. You see from the graph the tremendous increase of mental health problems, schizophrenia, mood disorders, and all the others, because really of the higher temperature. During the period of high temperature, the hospital admissions because of mental health is increasing tremendously. And this is going to be one of the major future problems. Actually, the budget spent for mental health problems in the world is close to $2 billion American dollars. It is expected that this is going to increase to about 30 billion American dollars by 2050. So the problem of mental health is going to be one of the very serious problems in the future. Next one, please. And this is very much, let's say, related to social problems. Who is mainly affected really by, let's say, the overheating, and who is really having mental problems in the society? Recent study shows that those that they are more affected is the low-income population. You see the results from UK and the distribution of the mental health problems and the need for mental health really assistance as a function of the income. And you see that those with the low income in the left part of the graph really needs about 260% higher, let's say, assistance and support, psychological support, than the high income population. Next one. And unfortunately, this brings us to another serious problem which is not well known: the increase of the suicide rate as a function of temperature. A serious problem that happens really in many countries now. For example, a very recent study in Mexico and the United States showed that above 21 degrees, suicide rate in United States is increasing by 0.7% per degree, while in Mexico is increasing by 2.1% per degree. It is tremendous. A very recent study published 2-3 weeks ago in New South Wales in Australia showed that suicide rate of young population is increasing by 1.5% per degree really in Australia, in New South Wales. And of course, this is going to be a very serious problem in the future if really we don't take the proper measures. Next one, please. Unfortunately, the problems of overheating are not really limited to environmental, energy, or social problems. Overheating is affecting very much the cognitive performance of students. We now know that exposure to high temperatures of students during the last 4 years affects their cognitive performance. And we may have a serious impact and a serious loss of cognitive performance when students are exposed to high temperatures during the last 4 years. For example, we know through, let's say, different standards and different, let's say, assessments that because of the overheating, students in Brazil, they have 6% less performance than the South Korean counterparts per year. Next one, please. And because of the, let's say, the previous one, please. The previous one. Thank you. And because of the non-proper conditions in the schools of the low-income population, for example, in the United States, Black students and Hispanic students, they present about 60% lower performance in, let's say, the national examination than the white population. So the problem of the loss of cognitive performance because of the overheating starts to be a very serious problem, and it is expected, next one please, that if we don't have the proper measure, let's say by 2050, the American students may lose about 8 to 10% of their cognitive performance by 2050. So this is going to be a very serious problem also in the future caused by the overheating. Next one, please. And unfortunately, overheating is affecting very much injuries and let's say illnesses. We know very well that during the period of high temperature, the number of injuries and the number of accidents is increasing almost exponentially. And this caused a lot of, let's say, financial losses for the countries. It is characteristic that during the last, let's say, heat wave in India, about 90% of the workers, let's say, working outdoors were not possible really to operate, and this had a tremendous impact on the economy of India. Next one, please. Just to understand the impact of the economic and financial loss because really of the overheating and the loss of working time, in the United States, they are losing about 100 billion annually from heat-induced loss of labor productivity. And it is expected that the economy really will be reduced or will have about, let's say, 23% lower income by 2100, by the end of the century because of the loss of, let's say, caused by let's say, decreased labor productivity. And this mainly happen in, let's say, the third countries, in the less developed countries, where people is working mainly outdoors. Next one, please. And recent studies that have been performed using, let's say, many millions of people have shown that the human productivity is decreasing by about, let's say, 60% above 30 degrees. You see the results, for example, when temperature is higher than, let's say, 30 degrees and goes close to 40 degrees, which is very common, let's say, in Southeast Asia, human productivity may decrease up to 60%. So it is very simple to understand the economic impact that has really to the countries and also, let's say, to the families because of the loss of productivity. Next one, please. And a very recent study by the World Labor, let's say, Organization, saw really the total work time that is expected to be lost, especially, let's say, in the, let's say, the developing countries because of the overheating. You see that officially, according to the World, let's say, Work Organization, temperatures close to 40 degrees, very common in cities in Southeast Asia, may cause a decrease of, let's say, by 70%. Next one, please. And this, unfortunately, affects mainly countries with, let's say, less income, developing countries, countries that are not responsible for the climatic change. So those that they are paying the penalty of, let's say, climatic change are those that they don't really are responsible, that they have not caused the problem. Next one, please. And the recent forecast show that these countries will be affected financially, but not only financially, also from the social and also from the technological point of view in the future. What's about the future? The actual, let's say, forecast we have about the future temperature in our cities show that we may expect an increase of the nighttime temperature between 3 to 5 degrees, not the same everywhere, but this is the average. And also, we are expecting an increase of the daytime temperature between 1 to 2 degrees. So in the future, we may have much higher temperatures during the night, less, let's say, decrease, but higher temperatures during also the daytime. Next one. And next one. And this really brings us to a very serious problem really regarding mainly low-income population. Why? Actually, about 9% of the global population is living out, of the so-called human climate niche, which is really the range of temperature where human, let's say, civilization is developed. 9% of the global population in our days is living out of this range, is living under temperature conditions that we never had before. And of course, this may increase up to, let's say, 40% in the future under specific conditions. Next one, please. And this will happen in very specific countries: India, Nigeria, Indonesia, Philippines, Pakistan, etc. So in these countries, we may expect a tremendous increase of the temperature, really because of the combination of the global and local climatic change. Next one, please. And this will affect mainly, let's say, low-income population. Just to understand that actually in the countries, in the cities of the Southeast Asia, we have about 86, in average, 86 days above 35 degrees. An increase of the temperature by 2 degrees will increase, this figure to about 105, or an increase by 3 degrees, very probably, to 134. Next one, please. But this is going to affect mainly the low-income population, because actually low-income population experience 83 days above 35 degrees, while high-income population has only 16 days above 35 degrees. So actually the problem is that in many cities in Southeast Asia mainly, but not only Southeast Asia, we'll expect a tremendous increase of the temperature. We expect also a very serious problem for low-income population. Next one, please. And under different, let's say, in various scenarios, the situation may be extremely, let's say, serious, but we like really to believe that these scenarios will not really happen, because it shows that perhaps, the increase of the population living out of the actual temperature range in Southeast Asia may increase by, let's say, 150%. Next one, please. I hate this really forecast, but unfortunately, this brings us to the reality of the actual construction, let's say, situation. There is currently a shortfall of about 330 million homes in the world. And in our days, this has increased to about 440 million by, let's say, in our days. We built a lot, but we don't build with the proper standards. And to understand really how much we built, I have to tell you that we had a total floor area equal to the city of Paris per week. So if these new constructions are not really meet the proper standards, we may expect a tremendous problem, especially in the countries of low-income population. Next one, please. And many people, they just mentioned that, okay, higher temperatures, low-income population, no problem, we have air conditioning. Actually, air conditioning is not really an important part of the energy, of the building's energy, let's say, balance. It's about 14–15%. But by 2050, it is expected that the need for air conditioning may increase up to 2,000%. Why? Because of the overheating and because of the overpopulation. Forecast shows that the total cooling energy consumption of a single Indian city, Mumbai, may be higher than the total energy consumption, total electricity consumption of the whole United States. So you understand what is going to happen really in these cities, and I will come back to this and explain you really what is happening today. Next one, please. Who benefits really from air conditioning? Is air conditioning a real, let's say, solution for the overheating and for the low-income population? Studies show now that those that they benefit in developing countries from air conditioning is the high-income population. You see the distribution of the penetration of air conditioning as a function of income in 4 developing countries: Brazil, Mexico, India, Indonesia. You see in the left part the low-income population, in the right part the high-income population. As you can see, the penetration of air conditioning in the low-income population is really very low because they cannot afford it. In Mexico it's 2%. In Brazil, which is a little bit more developed, it's 40%. In Indonesia, it's 3%. So, unfortunately, low-income population cannot benefit from the air conditioning for different reasons that we will explain, but because of the affordability, really, that does not allow to these families to use air conditioning. Next one, please. And other studies that have been performed very recently have shown that really in low-income population, the penetration of air conditioning, these are results from Brazil, is almost zero. They don't have, or they try really to cool their houses or really to have access to comfort really using other techniques. So air conditioning is not really a solution for the low-income population and cannot compensate the tremendous increase of the population and also the tremendous increase of the overheating. Next one, please. And this is the forecast for 2050. As you can see, low-income population will not have benefit and will not have access to air conditioning. Next one, please. And of course, this has a tremendous stratification in the world. Countries with higher income, they pay much less. The cost per family is much lower than in the countries with lower income. And why this? Because of the quality really of the electricity infrastructure, because of the quality of the housing, and because of many, let's say, social, financial, and technological problems. The cost of air conditioning in the low-income countries is much, much higher than the cost really of air conditioning in the developed countries. Next one, please. The same, you see, for example, how really the cost is distributed across the income. Next one, please. And also, you can see from recent statistics, official statistics, the cost per family of the air conditioning in the different countries as a function of the income. You see, for example, even in the United States, that low-income population, families, households really of low income, they are paying 10 times more for air conditioning than the high-income population. The same, for example, in many parts of the world. See in Italy, for example, a very developed country, or see, for example, what is happening in Africa. So it's not only the lack of access, it's also the very high cost the low-income population has to pay for the air conditioning. Next one, please. Because really speaking about the future, some people may say, okay, we believe or we don't believe. I like to show you what is happening actually in India. In India, since April 2023, in most parts of Southeast Asia, there is a continuous really heat wave, very high temperature. Because of the very high temperature, low-income population tried really to have access to comfort. And it's not so difficult really and so expensive to buy an air conditioning because of the market which is created by the air conditioning industry. You can easily buy an air conditioner. The problem is how to operate it. So in this kind of houses, you can see without any infrastructure, we install and they install in India everywhere air conditioners. The Indian government, to solve the tremendous problem of peak electricity demand, banned the, let's say, installation of air conditioners without a prior, let's say, prior approval by the government. But who cares about it? They buy air conditioning, they install it. Next one, please. As a result of this tremendous penetration during, let's say, the last 2 years in India, the peak electricity demand in India has increased by 15.2%. This is an incredible, let's say, percentage. There is no country in the world that can increase its capacity and power output by 15.2% per year. 15.2% per year new power plants. Who can do that? Which is the cost? Which kind of fuel? Which is really the total cost of electricity? What's about the emissions? What's about really the release of pollutants? It is impossible really to continue this way. As a result of this tremendous increase of, let's say, electricity caused by the limited penetration of air conditioning, next one please. No, previous, no, there's, can you go back one? Thank you. The provision of electricity in Indian cities during heat waves is just for 3 or 4 hours per day. So you understand that you can buy an air conditioner, but you don't have electricity because the tremendous real infrastructure which is requested and required, and the tremendous cost, and the failures of the grid, and do not allow it really to, let's say, provide comfort. So air conditioning is not really the solution for the future if we don't have other proper measures at the same time. These are the bad news. Next one, please. Do we have good news? Yes. During the last 15-20 years, there is a very, let's say, important research that has been carried out trying really to develop mitigation and heat mitigation technologies to decrease the temperature of our cities. And of course, I don't have the time to go through, let's say, all the mitigation technologies. Next one, please. But I like really to refer to very recent, let's say, developments that are related to the, let's say, development of the so-called supercool materials. These supercool materials, or photonic materials, are materials which really present a very high reflectance to solar radiation, 96-97%, but the most important optical characteristic, it has to do with the emission of these materials. These materials emit to wavelengths corresponding to the atmospheric window. The atmospheric window, 8 to 13 micrometers, allows the radiation which is coming from the ground to escape to space. So these materials can send the excess heat directly to space. So they can really develop temperatures or surface temperatures below the ambient one. Next one, please. In, let's say, University of New South Wales, we have developed these super cool materials. I don't like to go through the details. I like really to show the results. Next one, please. These materials are tested under, let's say, the Australian desert conditions. Very high temperature, very high solar radiation. Next one. And during the day, under the sun, during the summer, in the Australian desert, these materials present almost 8 degrees lower surface temperature than the ambient one. So these materials are natural air conditioners. Next one, please. And recently, together with, let's say, UCL in London, we have developed very cheap supercool materials under the form of paints, which also are tested, next one please, and present these paints applied on the roof of a house may present under the sun during the summer almost 7-8 degrees lower surface temperature, contributing to, let's say, much lower indoor temperature and of course much better thermal comfort. Next one please. Unfortunately, these supercool materials present very high reflectance. So these materials can be used only on the roof, let's say, of buildings, because if used on vertical surfaces may cause some problems of glare, contrast, etc. In order really to solve this problem, next one please, we try really to decrease the reflectance of the materials and compensate the loss of the reflectance by just using another cooling mechanism. And we use fluorescence. Fluorescent materials absorb solar radiation or radiation, but immediately they emit most of the radiation in other wavelengths. So their balance, really thermal balance, can be close to zero. The combination, next one please, of photonic with fluorescent material given us some color photonic supercool materials. Materials which have any color you may wish and present much lower surface temperature. Next one please. We have tested this material under the Australian desert conditions, and you can see, for example, that a colored material, for example, a green material, present almost the same surface temperature than a white, let's say, high reflectance photonic material. So now we can have color materials which present 8 to 9 degrees lower surface temperature than the ambient one. And these materials, next one please, present, for example, a red material, which usually is much more, let's say, warmer than a white material. These materials presented 4 degrees lower surface temperature than a conventional white. So you understand that these materials may be used in cities really to decrease their surface temperature and also their ambient temperature. Next one, please. So while 20 years ago, the surface temperature of cities was quite high, you see in the upper part of the graph. Now we have really the technological developments to decrease the surface temperature of cities up to 15 or 20 degrees. So this is a major achievement. And you may ask me, next one please, if we have any implementation of these technologies. Actually, in Riyadh, Saudi Arabia, we are responsible for the whole mitigation, let's say, plan of the city. We have designed, and now it is under implementation, the, let's say, use of the supercool materials on the roof of the buildings, on the whole area of the center of Riyadh. According to our calculations and the first measurements, we are able to decrease the peak temperature of the city in Riyadh up to 4.5 degrees. So this is the highest decrease of the temperature in a city. Next one, please. And our calculation, building by building, shown that the implementation of these materials and these techniques in buildings may decrease the energy consumption in Riyadh, a very, very hot city, up to 35%. Next one, please. But also, similar studies performed for, let's say, the Ministry of Energy in Australia, shown that the implementation of these technologies in Sydney may decrease the peak cooling demand in Sydney between 30 to 50%. Next one, please. But the most important, in my opinion, development and impact, it has to do with, let's say, the decrease of the temperature of low-income houses. These are experimental results that shows that when these, let's say, materials are implemented, used on the roof of a low-income house in, let's say, the desert of, let's say, in the First Nations of Australia or in Western Sydney, decreases the peak indoor temperature during the summer up to 10 degrees. So instead of having people living under 40 degrees or even 45 degrees, we decrease the temperature with a minimum cost down to 30, providing comfort and saving lives. Next one, please. What about the future? I tried really to describe you the very recent developments. I like to refer to the recent letter sent by the director of NASA to, let's say, Nature Journal. According to the director of NASA, the overheating, let's say, rate was 0.2 degrees per decade. Unfortunately, since 2003, the, let's say, overheating rate or the increase of the temperature is 0.2 degrees per year. According to the gentleman, we are in uncharted windows because we don't know why this happened. There are several explanations. We don't have to go through that. But this is what really happens. There is a tremendous acceleration of the overheating in our cities in the world, despite, let's say, the belief of some people that they think that there is no, let's say, climatic change. Next one, please. Is technology the only tool we have to use in order really to, let's say, mitigate and adapt to climatic change? No. Technology is very important, but it's not enough. Technology has to be combined with financial and social measures. Actually, in our, let's say, world, the cost or the, if you like, the implementation and the penetration of the new technologies is not only a function of performance, it is also a function of some financial indicators. In order really to accelerate the penetration of the mitigation technologies, we have to monetize the cost of the overheating. What does it mean to monetize the cost? It means that those that they increase the temperature, they have to pay for it. They have to pay the real cost of the overheating. And those that they contribute to decrease the temperature, they need to have benefits. Which means, next one please, that we have to develop a financial mechanism in cities where really that those that they cause extreme or excess warming, they have to pay for this cost. If your municipality really uses black asphalt and increases the temperature, if a new developer built, a new settlement and increases the temperature, if they have to pay for the cost. And those in the city that they really decrease the temperature by planting trees, by using proper materials, they have to gain really these benefits. So by creating such a financial mechanism, the monetization of the overheating will accelerate the penetration of the new technologies. So I like to concentrate and really conclude. Overheating is a very serious problem. I try really to present you the main impacts. I try at the same time to show you what will happen in the future. And I try also to present you the positive things, the developments we have. But we have to understand, it's not just a technological problem. It's a problem which combines really financial, technological, social issues, and we need to have an holistic real approach for the future. Thank you so much.
Well, thank you very much, Professor Matt Santamaris. That was a fantastic presentation. I've been listening to your speeches before as well, and every time there's something new, every time there is a message that is worthwhile considering and very enlightening. Thank you very much for sharing the great presentation and your valuable insight. I want to now open the floor. If there is any questions, you can use the chat, or April, if you have received any question, please let me know. While we are waiting for the questions to arrive, yes, have you got anything yet?
We don't have any questions until now.
No worries. So while we're waiting for people to type in their questions, I do have a few questions as well, Matt. I mean, these are fantastic statistics and research that you presented. My question is, and again, you alluded toward that end of your presentation, but my question is, what governments can do in order to help mitigate these issues? Because again, as you mentioned, people and municipalities, they're just putting black asphalt there. And some of them are a bit more reasonable, putting trees and using material that reduces the impact on the environment. But I mean, overall, what countries can do in order to battle this issue?
Actually, countries, they have to do, let's say, two specific things. First, decrease the heat gains in cities. The heat gains in cities are because first of the anthropogenic heat. We have to decrease, all the anthropogenic heat. Means, traffic, industry, everything. Second, we have to increase the losses. Increase the losses means more greenery, more water, let's say proper materials, and so on. And governments have to be, and decision makers have to be consistent with the scientific developments. The major problem we have with us actually is that in cities we don't follow, or they don't follow, a scientific approach. They follow an empirical approach. An empirical approach is an approach that says that we believe that trees decreases the temperature in cities. Let's plant 5 million trees. Is it enough? No. This may cause a lot of problems, may increase the temperature in cities under specific conditions, may increase tremendously the use of water, may increase tremendously the pollution, may decrease the temperature at the same time. So we need to have a scientific approach. Heat mitigation is a science, and we have scientific tools and scientific approach, which means first, we need to identify the problem. The reason of the overheating in Melbourne is not the same reason in Singapore or in Athens or in Sydney. Given that the reason of the overheating is not the same, the methods and the medicines we have to use, the mitigation technologies, may not be the same. A technology that is used, for example, in Sydney and has given good results may not perform quite well in Singapore or in London because do not really correspond to the problem. So in cities, we need really to associate the problems with the proper mitigation technologies. This is the scientific approach, and also to optimize the use. Unfortunately, decision makers, they like very much simplistic approaches and simplistic solutions. Let's plant trees. Yes, but do you know really the impact of trees? For example, in Sydney, the initial plan, which is abandoned now, to plant 5 million trees, may increase the use of water by 35%. We don't have the water. And the benefit may be 1 degree of lower temperature during the day, 2 degrees during the night. We need to have approaches which are not based on, let's say, the empirical approach of some people. Those that really then consult the decision makers, unfortunately, this is a serious problem, also a social problem, are not really the proper people. They are people which are close to the, let's say, decision makers, proposing simplistic solutions, easy to implement, with a high cost sometimes, but without results. So decision makers, in conclusion, they need to understand that they have to implement scientific approaches. You cannot solve and you cannot cure really cancer by using traditional Chinese medicine. This is very clear.
No, absolutely. Well, thank you. We have few comments and questions also coming from the audience. Margarita has said an excellent speech, and as always, Farida asked for the research on thermal environment or energy health. Which methodological innovation are you most looking forward to seeing?
I'm not sure I have understood the question.
Well, I can read. I mean, you can see the question also in the chat if you want.
Yeah.
It says, for the research on thermal environment and energy health, which methodological innovations are you most looking forward to seeing? Maybe Farida, if you can elaborate more on your question, that would be great.
Yeah, because the thermal environment, the built environment is huge, and the methodologies used are really many. We use different methodologies really to let's say, implement innovative techniques in the outdoor environment and in the indoor environment, indoor air quality. There are many methodologies. So if Frida can be a little bit more specific, yeah.
Yeah, absolutely. So just being conscious of time, I do have one more question, and then if there's no other question from the floor, we can close the session. At the end of your presentation, you mentioned a proposal for monetizing the impact on the temperature. So those who are increasing the temperature, they should pay more, and those who are contributing to reducing the temperature should be receiving incentives. We may have the same scenario when we're talking about, for example, energy efficiency, but one of the challenges is validating the outcome for something that you make an action and then there is a prevention. How you want to monetize that prevention or the amount of the temperature that has been reduced due to your
Yeah.
action. Of course, there are methodologies, but then have you thought of how we would be able to validate that impact so we can monetize it?
Yeah, this is an excellent question, and in the frame of the European Bauhaus project, which is a project of 1 trillion euros, really trying to decrease the temperature in cities and let's say decrease by 80-90% the emission of CO2 and greenhouse gases in European cities, we have developed such a methodology, you know, and what really is increasing the temperature in our cities by the building sector. The release of anthropogenic heat and the release of sensible heat. So actually, we can easily, for example, we have a new settlement. Imagine that we design a new settlement. We can easily calculate really the release of the anthropogenic heat. And also we know very well how to calculate the release of sensible heat through simulation, etc. So if we put a threshold, that this is the, let's say, the allowed, let's say, magnitude of anthropogenic heat or sensible heat to be released. Above it, you have to pay. Below it, you know, you need to have incentives. So there is a very clear methodology that has been developed. Of course, it has to be implemented.
Yeah.
There is a criticism about it that may increase the cost. I have to tell you that the cost of the inaction, of non-action, actually is close, let's say, to $10 trillion, and is going to be close to $50 trillion by 2050. So those that believe that the implementation of mitigation and adaptation technologies will increase the cost in the built environment, they are completely wrong. Because the cost is there, we pay for it, and the cost will increase tremendously in the near future. So in reality, we have really to think about it. And the increase of the cost is not really a challenge. It is an opportunity. Why? Because it offers new possibilities for industry. It offers new possibility for commerce. It offers new possibility for innovation. So we have really to take advantage of these new developments in order really to improve the built environment and also transform or translate the challenge into opportunity.
Absolutely. Well, that's great. I really look forward to seeing a day that these type of schemes are implemented by government across the world. So that would be fantastic. I don't see any other questions coming from the floor. With that, I would like to again thank you, Matt, for your fantastic presentation. It's always pleasure listening to your speech. Well, thank you very much, and enjoy the rest of your day.
Thank you so much. Thank you for the invitation, and thank you very much.
Thank you. Thank you very much, everyone, for your attendees. And I believe that the recording or the slides would be available later on as well. So, yeah, thank you. Enjoy the rest of your day.